Okay guys, welcome back to another session on Laplace transformation. So basically we concluded the derivation of our standard solutions to Laplace transformation, right, based on our last video. So today we are going to move on to the next stage, which is um, getting to know how to apply those derivations we did based on our previous classes or our previous lessons. So today we're going to be taking two basic factors to note when applying Laplace transformation. And the first one is we are going to be considering the Laplace transformation of the sum or differences of two functions. Now, for example, it says the transform of a sum or difference of an expression is the sum or difference of the individual transform, meaning that the Laplace or the transform of two functions which are adding or subtracting themselves is the Laplace of the individual functions, then adding it or subtracting them. Now look, I'm going to read it again. I said the transform of a sum or difference of an expression is the sum or difference of the individual transform, meaning that the Laplace of two functions which are adding themselves or subtracting themselves is equal to the Laplace of splitting them together, taking the Laplace of each of the functions, then adding them. It's a very simple theorem. So now let's take an example. So basically we're going to be looking at this example which says find the Laplace of exponential of 2t plus t squared. Now we're going to be following this rule. Now remember, this rule says the transform of a sum or difference of an expression is the sum or difference of the individual transforms. Now this is an expression. These are two functions of t. Now this is first function and this is second function. They are adding themselves together. So we have to find the Laplace of the sum of these two expressions. So basically we are going to be following this rule which says this to be the Laplace of their individual functions. So we are going to be taking the Laplace of this and the Laplace of this. So following this rule, we say the Laplace of this plus this is equal to the Laplace of this plus the Laplace of that. So following that rule, we'll be taking this, we'll have Laplace of exponential 2t plus Laplace of t squared. Now if you can remember, based on our last videos we did, we derived some basic solutions to Laplace expression. So basically we said that the Laplace, now this is where those derivations comes handy. So I believe you have actually crammed about 5 or so. So I believe you have actually noted down some derivation, because without those derivation you can't actually be able to solve any Laplace solution, any Laplace problems. So based on our last video, we derived that the Laplace of exponential at is equal to what? 1 divided by s minus a, right? So now we are going to be making use of this theorem to solve this, because if you compare these together, they are actually the same form. This is exponential at where a is a constant, right? So now we are having exponential 2t here, right here. So basically we are going to be making use of this, right? So the Laplace of exponential 2t is giving us what? So Laplace of exponential 2t right now is equal to what? 1 divided by s minus 2, right? So we have gotten the Laplace of this, right? Plus Laplace of t squared, right? So now to get the Laplace of t squared, now if you can also remember, based on I think it was the last video we did, to get the Laplace of t raised to power n, right? We said the Laplace of t raised to power n is equal to what? N factorial divided by s raised to power n plus 1. This is the last derivation video we did to get the Laplace of t raised to power any constant or t raised to power. This is an arithmetic function. So the Laplace of an arithmetic function raised to power n, any nth order. So the Laplace of t raised to power n, we did it on got in our last video to be n factorial divided by s raised to power n plus 1. So we are going to be using this to solve this. So Laplace of t squared, which is equal to Laplace of t squared is equal to what? 2 factorial, right? Divided by s raised to power 2 plus 1. So 2 factorial divided by s raised to power 2 plus 1, which is equal to 2 divided by s raised to power 3. So let me write it in a more clear terms. So we'll be having something like this. So I said Laplace of exponential 2t which is equal to 1 divided by x minus 2, right? I said, and I also said, you have to find the Laplace of t square, and I said the Laplace of t raised to the power n is equal to n factorial divided by s raised to the power n plus 1, right? So basically using this based on this is the last derivation we did in our last video. So using this, so the Laplace of t raised to the power t square, right, is equal to 2 factorial divided by s raised to the power 2 plus 1, where n is equal to 2, right? So having this, we'll be having 2 divided by s raised to the power 3. So we have gotten the two answers to the Laplace of this. So now let's write it out. So writing it out. So continuing from where we stopped, right? So we said the Laplace of exponential 2t is 1 divided by s minus 2, and the Laplace of t square is 2 divided by s raised to the power 3. Right? So now this is the answer we have, or you can just choose to simplify it in a more detail, or you can leave the answer like this. So now I'm going to take in the second example. This is find the Laplace of cos 3t plus exponential minus t. Now I believe we all can actually work this one out, so now let's do it together. So finding the Laplace of cos 3t plus exponential minus 3t. Now the rule says the Laplace of two functions adding themselves is also equal to the Laplace of the individual function. So we are going to take in the Laplace of the individual function, which is Laplace of cos 3t plus Laplace of exponential minus t. Right? So now we're going to be taking notes of our rule which we derived based on our last video, which says the Laplace of cos 80 is equal to what? Laplace of cos 80 is equal to what? Laplace of cos 80 is equal to s divided by x squared plus a squared. Right? We did it based on our, I think it should be the fourth video or the third video we did derive together. So I urge you guys to go back if you can't actually remember how we derived this. I urge you to go back to see how we derived the last video. So we are going to be making use of this rule now to solve this, right? So the Laplace of cos 3t now is equal to what? So if the Laplace of cos 80 is equal to s divided by s squared plus a squared, where a is equal to 3, right? So Laplace of cos 3t now is equal to what? S. So Laplace of cos 3t now is equal to what? S divided by s squared plus what? 3 squared. Right? Remember I said Laplace of cos 80 is equal to s divided by s squared plus a squared, where a is equal to 3, right? So substituting 3 to this function here, we will be having this, right? So now Laplace of exponential minus t. Recall we said that the Laplace of exponential 80 is equal to what? 1 divided by s minus a, right? So now if the Laplace of exponential 80 is equal to 1 divided by s minus a, comparing this with this, my a is equal to what? My a is equal to minus 1, right? Comparing exponential minus t with exponential 80. Exponential minus t with exponential 80, my a is equal to what? Minus 1, right? So eventually the Laplace of exponential minus 80 will be equal to what? 1 divided by s minus, my a is what? Minus 1, right? Divided by minus 1. So this gives me s divided by s squared plus 9 plus 1 divided by s plus 1. So now this is the answer. You can choose to simplify it by taking out the LCM. So we'll be having this. If we choose to take out the LCM, we'll be having this. So simplifying this, we'll be having taking the LCM of this and this, which is equal to s squared plus 9 s plus 1, right? S squared plus 9 plus s squared plus 1 in this will be left with s divided by s plus 1 plus this in this will be having s squared plus 9. So simplifying this will be having this plus this times this, that's s squared plus s squared, that's 2x squared, s times this, that's s, so 2x squared plus s plus 9 divided by s squared plus 9 s plus 1. So either you can choose to leave your answer like this, or you can leave your answer like this. They are both correct. So now let's take our second rule. So we're going to be taking notes of our second rule, right? So our second rule says the transform of an expression that is multiplied by a constant a, right, is the constant multiplied by the transform of the expression. So now this is the transform of this expression, right? Now this is the transform of this expression, but this expression is multiplied by a constant a. A can be any number, right? So now to solve this, right, so it says it is the constant multiplied by the transform of the expression. So basically we are just removing out this constant, just like when we want to integrate, and there's a constant in front of the function we want to integrate. We just take the constant at the back of the integral sign, then integrate what we want to integrate. So now the same thing applies for Laplace transform. So now basically this is a constant times the function of t, right? So we're basically going to be taking out this constant to the back of the Laplace sign or the Laplace symbol, then solving our Laplace function. This is a very easy rule. So I'm going to take it again. I said the transform of an expression that is multiplied by a constant is the constant multiplied by the transform of the expression. So basically the transform of this expression multiplied by a constant is the constant itself taken out of the equation multiplied by the Laplace of the function. So I'm going to be taking one example. So now taking one example, right? So we're going to be making use of this same rule, right? Basically, this is the most simplest rule. So basically, what do I have to do? Now this is a constant, right? 4 is a constant. Now it's multiplying the function we need to transform, right? So now the rule says taking out the constant in front of the Laplace, then doing away with just basically taking the constant in front of the Laplace function, then solving it, right? So now this is 4 times exponential 2t, right? So the rule says the 4 will go out, right? So we'll be having 4 times Laplace of exponential 2t. So now I'm going to find the Laplace of exponential 2t. Now if you can recall, we says the Laplace of exponential at is equal to 1 divided by s minus a, right? So comparing exponential at with exponential 2t, a is equal to what? 2. So we'll be having, right? So we'll be having 4 times 1 divided by s minus 2. So this is equal to 4 divided by s minus 2. So this is basically the Laplace of this function. So now let's take at least one more example, then that is all. So now in our next video we'll be treating some theorems that can really help us to solve Laplace transformation. So now let's take our last example on try to crown it all on the 2 theorems we just finished solving. So now let's take this one last example. So now it says find the Laplace of 2 cos 6t minus 3 sine 3t. Now both of them are basically hyperbolic function, right? And if you can remember, based on our fourth or third video, we treated how to calculate the Laplace of hyperbolic function, right? So now if you have not actually watched the video, so you can't actually understand what I'm about to do here, but I will actually make it understandable. So we have to find the Laplace of 2 cos 6t minus 3 sine 3t. Now, so our first rule we just finished taking says the Laplace of the sum or difference is actually a minus sign. So the Laplace of the sum or difference of 2 functions is actually the Laplace of their individual sum. We are going to be taking the Laplace of the individual of this minus the Laplace of the individual. So now let's go. So the rule says we'll be having Laplace of 2 cos 6t minus Laplace of 3 sine 3t. Right? So I've actually carried out the first rule. Now the second rule says the Laplace of a constant multiplied by a function is equal to the constant times the Laplace of that function. So now we're having a constant here which is 2, right? So the Laplace of 2 cos 6t is equal to what? Following the second rule, it says 2 times the Laplace of cos 6t minus the Laplace of 3 sine 3t. 3 is a constant, right? Times this is the function, right? So it will be what? 3 times the Laplace of sine 3t. So the Laplace of cos 6t. Now if you can remember what we derived based on our second to the last video, we said the Laplace of cos 8t is equal to s divided by s squared minus a squared. Now this is actually very similar to the Laplace of cos 8t, but the difference is just the minus sign, right? for Laplace of cos 80 there's a plus sign, for the Laplace of cos 80 there's a minus sign, and the Laplace of sine 80, which we derived, at least I think our third video, we said is equal to a divided by s square minus a square. This is also very similar to the Laplace of sine 80, but the only thing that is just the difference in their sign. So now we're following these two rules. The Laplace of cos 60 now is equal to what? Going to be 2 times s divided by s square minus 6, right? This is 6 square minus 3 times Laplace of sine 3t. Following this rule, this is going to be fully comparing this to a is equal to 3, right? So this is 3 divided by s square minus 3 square. So simplifying this more for that, so this is 2s, 2 times 3, that's 2s divided by s square minus 36 minus 9 divided by s square minus 9. So this is our answer. So please and please do so well to subscribe.